Now we're going to learn how to measure the length or the magnitude of a vector by using the Pythagoras theorem, which is the square of the hypotenuse equals the sum of the squares of the two other sides. Okay, so a squared equals a squared for the y-axis and a squared for the x-axis. As you can see here, we have here the y-axis, and you can see here the x-axis. We have the vector A and vector B. Vector A has 2 points, which is 2 and 2. So we're going to take the square root of point A for the y-axis, which is 2 squared, and the square root of the x-axis, which is this one, because this refers to the y-axis and the other one refers to the x-axis. So 2 squared is 4, and other 2 squared is also 4, equals 8. Okay, 8 is a squared, and we want the value of the individual a. So how do we achieve that? By taking the square root of the result. Okay, square root of 8 is approximately 2.83. Okay? The magnitude of A is the form of, it means it doesn't have any negative or positive forms. Okay? The raw form of A. Okay? And A is the modules of vector A. Even if you have like -2, you just write it as 2 because these brackets or these lines means the modulus of a vector. We always put it in a positive form. It doesn't have any negative form. Vector addition triangle for the Parallelogram rule. Vectors can be written in bold, underlined, or with a line or arrow across the top to distinguish them from scalars, which are quantities without direction. Okay, so this is a vector. Okay, and this is a vector. We're gonna look for equation for the Pythagoras theorem. Unit basis vectors. Basis vectors indicate the direction of axes. Okay, we have here the y-axis and here the x-axis. Okay, you can see the red line. It indicates the j and the I. Okay, j and the I indicate the direction of each one, and they have the length of 1 unit. Okay, so I means 1 to 0, and j equals 1 to 0, both in the y-axis. Okay? Unit vectors are indicated with pointed hats, but in case of well-known basis vectors like I, j, and k, I and j, the hats are dropped. Okay, like it means this. We can write A in terms of its components. A equals 2i plus 2j, because we said that I and j, each of these unit or basic vectors, are well known, and they have the form of 1 unit. Okay, so we can take it as base for other unknown vectors like the point A that we have here. The point of A here, we have 2 and 2 for the y-axis and the x-axis. So we can use, how do we say this expression? Is by saying A vector equals 2i and 2j. Okay, we base on the unknown A vector to the known j and I vectors. Vector addition and components. As you can see here, we have the y-axis and the x-axis for B vector and A vector. The points of A are 2 and 2. The points of B are -2 and -3. Okay? You have here, as we said before, the I and J. This is for the x-axis, it's called an I, and for the y-axis, it's called a J. So for the y-axis, it's 3 and 0, and for the x-axis, sorry, and for the y-axis is 5 to the y-axis and 2 to the x-axis. So the distance, or d, is 2i plus 2j plus 3 from here. We don't add 0 because adding or not adding 0 will have the same result. We're going to open the brackets. Equals 2 plus 3 for the I. Okay? We're going to open the brackets. We're going to take for what's in common, which is the I. We're going to take it out. So we say 2 plus 3 for the A. Plus the odd one out, which is the 2j plus 2 equals 5i to 2 plus 2j. And the I component adds the I components and the j components. Because here we have the I component, and here that's coming out from this vector, we said the base vector, are are the j. So how do we take the value of this formula? We're going to take the value of x-axis and the value of y-axis. Of course, is the module value. Doesn't have any negative or positive value. In I and in j. Here, in I and in j. And we're going to add it to the value of I, which is a 3. We're going to divide, we are going to distribute the brackets to take out for what's in common, which is the I. We're going to sum them up. 2 plus 3 equals 5i, and the odd one out is 2j, and we're going to keep the form of it like this because we have different units or different values, which is I and j, so it's going to stay in the 5i plus 2j form. Resolving vectors in components. What are the lengths of the components of the vector r, which lies in y and x directions? Okay? As we said before, we're gonna have I and j are have each of them units of 1. Okay, and we're gonna use this law, and we're gonna take out the value of I and j. Now we have equations of constant acceleration. Velocity, we can know the value of velocity by dividing distance over time. The distance we refer to, or the symbol of, is s over t. The acceleration is velocity over time, v over t. So in order to know the value of acceleration, we have to first know the value of velocity. Okay, so maybe in the equation or the question, they are requiring the value of velocity, but they don't give you the direct value of acceleration, but they don't give you the direct value of velocity. You're gonna know the value of velocity from the first rule that we mentioned here. The average speed equals final speed plus the initial speed divided by 2. Okay? These questions are only applied in certain situations. Okay? General equation of constant acceleration. Here, the acceleration equals a constant. For example, acceleration due to gravity equals 9.81 meter per second squared, or the inverse of the meter per second. So, the acceleration equals gravity. The velocity equals the gravity multiplied by time, by time, like we said here, plus u. U is the symbol for the initial speed, and s is the initial position at the time 0. So the velocity equals gravity multiplied by time and added the u. The initial position equals half multiplied or 1 over 2 multiplied by gravity to time squared plus u multiplied by t plus the initial position at the time 0. Okay? So, hypothetically, if u equals 0, which means the object begins at rest. Uh, Usually, every object is at rest state and then it moves. So, this symbol to that exact state, which is uh, objects beginning at rest, which is 0. And the initial position or the initial speed, s to 0 is 0. We place the origin and the initial position. Okay? So if u equals 0, it means the objects at rest state, and s equals 0, it means they are in their initial position. Then, acceleration equals gravity. Velocity equals gravity multiplied by time. And acceleration equals half by gravity by time squared. Okay? So if we have these conditions, then we can apply this. Okay? If acceleration equals 0 and initial speed or initial position equals 0, an object has initial velocity. It means the initial velocity or the initial speed of u is equals constant. Then the value of acceleration is 0. The velocity equals the initial speed, and the acceleration equals the initial speed multiplied by time. Okay? So if you have these conditions in the equation, you're going to apply these three uh, rules or these three equations. If you have these conditions in the question, you're going to apply these three rules. Speed, velocity, and acceleration. For example, a 35-kilogram cheetah, initially standing still, accelerates at 7.2 meter per second squared in a straight line for 3 seconds. What is the maximum speed it attains after 3 seconds? What is the magnitude of the net force acting on the cheetah? And how far does it travel for 3 seconds? First, we have to know what is the maximum speed after 3 seconds. Speed equals the acceleration multiplied by time. So we can say 7.5 meter per second squared multiplied by 3 seconds is 22.5 meter per second. The force equals mass per acceleration or multiplied by acceleration. The mass of the cheetah is 35 kilograms and it accelerated at 7.5 meter per second squared. This equals 262.5 kilometers to the inverse of meters to the second inverse of meter second, which approximate this unit. Instead of writing this whole unit, you can just say Newton. Okay, so it equals to 262.5 Newton. The average speed, or we have the how far it travels, the average speed per time. You can know the amount of average speed by uh, saying the final speed minus the initial speed. This will come out in 11.25 meter per second multiplied by 3 seconds. So we will have the 33.75 meters. Okay?